In this video, we're going to look at the measures of the center of the data that we're looking at. So we talked about median already. Now we're going to talk about mean and mode and the weighted average. So when we talk about the center of the data, that's a way of describing how the data is set in front of us. Not really behaving, but kind of behaving. When we talk about the center, we're usually talking about the average. That's what the layman would call average. We call the mean, and the median, which we've talked about the median. So you're going to hear mean and average pretty interchangeable. When we're talking about the mean, it's an arithmetic mean, and average is technically a center location. But in practice, among non-statisticians, average is commonly accepted as arithmetic mean. So we have two different kinds of means. If you are thinking about what you're going to really need from this section, it's going to be the notation. So I would somewhere have on a note card important notations, because later when we use x bar versus mu, you'll need to note that x bar represents the sample mean and mu represents the population mean. So when I see x bar, that means it's the sample mean. When I see this Greek letter, it's pronounced mu, like a cat, mu. That's a population mean. And here's how you would find it by hand. Now, we're not going to ask you to do it by hand. I am not going to ask you to do this by hand. But how you would do it by hand is that you would sum up all the x's from your initial data input, x being the data input, your data piece, all the way up to however many data pieces you have. And you would divide it all by however many data pieces that you would have. And this would be how you would find the mean for the sample, x bar. Mu is similar, except for now we have the population size, which typically does not happen. But what we want to do is we want to have the sample mean be a good estimation of the population mean. So what ends up happening is something called the law of large numbers. And it says the samples you take are getting larger and larger in size, getting closer and closer to the population, then the sample mean is very likely to be closer and closer to the population mean. And we're going to talk about this later in this quarter, what the law of large numbers mean, and not the mean, like the center of data mean, what it is for us. So if I wanted to know the mean of this data, so the following data, number of patients typically wait on a transplant list before getting surgery. The data is ordered from smallest to largest, calculate the mean. Now, the way I would do this is I would add all of these up and then I'd divide by the number of data pieces. Now, I could do it on my calculator, but I'd probably grab this and put this in the spreadsheet. In the spreadsheet, you can actually find the mean. It's average, so you're going to use average, AVE, I think it is, and then you'd grab this data set. Now, since I don't have a spreadsheet, then I just get out a calculator and add all these up and divide by the number of data pieces, and when I did that, I got an answer of 13.95. That is my arithmetic mean. Now, the median, we know how to find the median. It means that the median is that halfway mark. We just did it in the previous two videos ago in 2.3, we did the median. The location, as you know, the location of the median is not the value of the median. They are not the same thing. And we know from finding the median from our previous one is that we take the number of data pieces that we have, we add one to it, divide by 2, which is basically what this is doing, number of data pieces plus 1 divided by 2, tells me the location. So I'm using the same data piece, the same data that I have, and to find the median, in this case, it is 13. So one of the ways that you could do this if you were doing it by hand is you can just mark off 3 and 24 and 4 and 24. And you just mark it off, one on either side. And this is slow as crap. But back in the day, before we had spreadsheets that used to do this lovely stuff for us, this is exactly how we would do it, which, as you can see, this is boring as shit. Schnizzle, like the worst. The mode. Now this is something new. The mode is the thing that happens the most. It's the data piece that happens the most. And we can have unimodal, which means we only have one data piece that is shown the most. That's unimodal. Or we have bimodal. So we have unimodal. That means we have one mode, and bimodal, which means we have two modes. So again, if I take a look at the same data piece and I would look to see which data piece happens the most, 7 happens 4 times, 10 happens 4 times. Looks like I have a bunch of them that happen 4 times. Oh no, 10 happens 1, 2, 3, 4, 5 times. So 10 is my mode. So 10 happens the most. The mode is the one that happens the most. Now, how do we find all this stuff with the frequency distribution table? Also, you might see this as FDT in the homework. FDD is a frequency distribution table. Now, this is something that you would want to have a spreadsheet because it's not a lot of fun to do this by hand. So I would add another column here and I would put CF for the cumulative frequency, not the relative cumulative frequency, but the cumulative frequency. So I'd add this column here, and there's the video that shows you how to do all this stuff. And the cumulative frequency would be 2, and then it's 6, 9, 12, and 20. So that also tells me how many data pieces I have. I have 20 data pieces. And then I would add another column, and I'm going to take my frequency, I'm going to call this F, and I'm going to multiply it by X. Well, what is X? X is my data piece. So what's going to go in this column? It would be 2 times 34. It would be 35 times 4. It would be 36 times 3, 37 times 3, and 38 times 3. And then I'd add all of these up. So I'd sum this up. That is a notation for sum, and I'd get 731. The mean is going to be that 731 divided by the 20 pieces, which is 36.5. Now, the median. Why did I do the median? Because I have to figure out what the position is for the reason I did this cumulative frequency part here, because I need to know the position. There are 20 pieces, so I do 20 plus 1, which is 2. So I need to look at 10.5. So I need to know where the 11th and 10th pieces are. The cumulative frequency tells me that the 10th and 11th are both here. It's number 37. So my median is going to be 37. Now my mode is the one that happens the most, and my mode is 38 because it happens the most. It happens 8 times. Now, how do you do the same mean, median, and mode from a frequency distribution table, also known as grouped frequency distribution table, also known as GFDT? Well, we're going to look at midpoints of the class. So what we're going to do is we're going to do the same kind of thing. We're going to add another table. We're going to add the cumulative frequency. So we're going to add the CF, 2, 4, 10, 24, 48, 58, 66, 66 because there's nothing to add there, 66, and then 73. So I know I have 73 pieces of data. I need to know the midpoint on this. So I'm going to do the midpoint of each class. So the midpoint between these two is going to be 72. And the next one is going to be 77. then 82, then 87, 92, 98, 102, 107, and obviously I've got off, I have 112. Okay, my F times X, F times X. Now this is my X and this is my F. So it would be, the first position would be 72 times 2, then 77 times 2, and then 82 times 6, then 87 times 14, 92, yeah, 92 is the next one, 92 times 24, 98 multiplied by 10, 102 multiplied by 8, 107 multiplied by 0, and then I'd have 112 multiplied by 7. I would then sum all of these up, and I get 6796, and so my mean would be 6796 divided by the number of pieces I had, which was 73 pieces. Now, where is my mode? So my mode is easy. We'll do mode next in this frequency class. And we choose the midpoint, which is 92. So 92 is the mode. Where is the location of my median? Well, the position is 73 plus 1 divided by 2. So 74 divided by 2 is position number 37. So I need to find out where 37 is. Well, position number 37 lands in, right here is 48. So 37 would be here, which means it's in this class, this bucket. So that means it would also be the midpoint. So the median is also 92. And that's it for this video. Nice short video. Please watch the extra videos on how to use spreadsheets to find all the stuff in the Canvas shell, or not if you like to do this by hand. We'll see you in class.